this work has spanned 2 semesters, and sort of taking on a life of its own. The Office of Force Transformation is very interested in what we're doing here, so we hope to progress this in future semesters. So if it has some interest to you, or you know some people that might want to get involved with this, please let me know. So we're looking for more bodies that can keep this thing moving along. Before I let Jeff begin, let me thank Bob Reninga and Scott McBride and Maggie Dean for their assistance and all support in getting this project off the ground and moving along. So, Jeff, if you want to begin.
Thank you very much, sir. Good afternoon. My name is First Class Jeff Wilcox, and I'm happy to say it's my last brief as a midshipman here, so that's definitely exciting. I'm also happy to see some people who have been to my first presentation and who decided to come back for more. All right. I'm going to be actually fortunate enough to hang around here for TAD until November 5th. And during that time, I'm going to be training my replacement for this ongoing project. So this, we pass the torch on, and this will continue to stay in midshipman hands long after I'm gone. And that being said, definitely looking forward to seeing where this goes next month. All right. First, I'm going to talk to you about power-centric warfare and what application that may have on training here at the United States Naval Academy with the implementation of the YP-TDS. I'm also going to talk to you about the way a flow training is currently conducted, what we use the YPs for, and an area that we see that could be improved with the application of the YP-TDS. And then after that, I'm going to actually show a demonstration of the system at its current state. Next slide, please. All right, network-centric warfare. Well, what is it? In a nutshell, net-centric warfare is sharing information. It is exchanging information in the context of military tactical information. So what it means is, if I have if I share with my allies everything that I see in here, and they share with me everything they see in here, then you as a decision maker become that much more informed. And this helps to mitigate what's known as the fog of war, which is the inherent utter chaos and confusion that needs to be overcome to coordinate multiple platforms widely dispersed. And this has a lot to do with the wide area network, which is what the emphasis on this semester work was on. Next slide, please. All right, the Air Patrol craft. I'm sure a majority of us in here, if not all of us, know what a YP is, but I'll just describe what they currently do. We use YPs, third class midshipmen, as well as first class. Over the summer block training, we take them to places like Rhode Island, Boston, and New York, and it gives the midshipmen a chance to taste the life at sea, albeit in a training environment. But the skills they learn there are going to help them out in the fleet. And the oceanography majors also use them for research. And notably absent from the role of the YP as a training platform is flow training in a tactical battle scenario. We don't really do that here. And this is something that the YP-TDS applied could cover. Next slide, please. All right. This is, as I mentioned, this is my project for the last 2 semesters. In the first semester, I was interested in only getting a local area network up and running and a tactical battle scenario simulation. This semester, I'm focusing on the wide area network exclusively. But I've also done some other minor improvements. The entire system is going to use just conventional off-the-shelf hardware. Nothing too terribly expensive. I'm using the HF radios that the YPs already possess, the North Star GPS system that the YPs already possess, as well as laptops, Ethernet cable, and anything you can buy off the shelf. And this will simulate sensors that the YPs do not possess, weapon systems that the YPs don't possess. And it'll also do what is known as Naval Tactical Data System display, and I'll get into that next slide.
Mr. Wilcox,
yes,
the benefit of the dinosaurs, could you talk a little bit about the difference between a local area network in the context of the YPs and a wide area network, what it meant when you went from one to the other?
Sir. Well, actually, beat me to the punch, sir. I have a...
Okay, it's coming in the slide.
It's coming, sir.
Right.
Thanks, sir. And something else. I encourage everybody to ask questions throughout the presentation. If you have anything I need to put. Next slide, please. All right, this here is the Naval Tactical Data System. It's where the YP gets its name from. The YP stands for Yard Patrol Tactical Data Simulator. And this is actually an in-simulation screenshot of what the YP-TDS displays for the user. Here you can hook tracks, and a track is any one of these symbols up here with a contact number right below it. And they come in 4 different major varieties. The blue ones are friendly. Those are guys who are on your side. The green ones are neutral, aircraft or surface ships. And then the red one's a hostile, and the yellow one is unknown. Unknown meaning that we can detect it with our sensors, but we don't know what its disposition is. For instance, track 0072 up there is unknown. Now what our system allows you to do is anybody who's connected to our wide area network who's on our side can actually designate track 0072 as a hostile, friendly, or neutral. And then that designation we broadcast out to all other YPs connected to the wide area network. And then if they choose to take any action against it, such as engage it or classify it as something else, then that information will be reflected to us too. Next slide, please. All right. The background of that chart that you saw, the waterways and the land masses, was converted from something called a BSB chart, which is nothing more than a scanned image of a paper chart. So it's very accurate. But we had to do some pre-processing. I'll go over it really quickly. First, you had to remove old grid lines, danger bearings, any text, anything that wasn't water or land. And then that would leave you with this image on the upper right, which isn't quite the right color. So I took the liberty of texturizing both water and land, and then I divided up into 35 different images, which can be used as tiles to render the background in the user display. So fundamentally, what the YP-TDS is aiming to do is to equip the YP with weapon systems and sensors that it doesn't normally have. So we're turning that upper left-hand picture there of the YP into a guided missile YP. This is represented in the lower left-hand corner. And YPG, in Navy nomenclature, being it's a guided missile. The YPG will be equipped with such weapon systems as the close-in weapon system, a deck gun, and a vertical launch system, as well as sensors and countermeasures that are found on a U.S. Navy Aegis cruiser. So basically, we're allowing the YPs to mimic, in a functionality sense, an Aegis cruiser while it's secret. All right, in addition to tactical training and tactical situational awareness and command and control, we also want to cover damage control. Now, the way that's handled is when your YP takes a virtual missile hit, you have 6 different zones on the YP, and this menu is accessible. This is an actual menu that you can access throughout the YP-TDS system. There are 6 zones that can take different types of damage. For instance, the deck gun here has been damaged 32% and is on fire. Effects such as fire and flooding are cumulative and will eventually sink the ship if not acted upon. So you would have to deploy a damage control party, which would be monitored by referees on board. As they conduct drills to the satisfaction of the referees will update this system and prevent the ship from flooding or burning. All right, as of last semester, this is pretty much where we left off with the local area network. I'll go over real quickly what the modules and software are. You have the user interface, which is all your clicks, all your keystrokes. You had your tactical and nautical displays at the bottom. Those would create all your NTDS symbols and a nautical display, land masses and water. Your own ship longitude and latitude was being fed to you from the GPS unit, so it's real time, your position. And then your network IO controller would control the wide area network this semester, as well as the local area network of last semester. And a scenario simulation is a bunch of data that sets up your scenario, where you are geographically in the world, and what civilian and automated contacts start off with you when you begin the simulation. And all of that is run by the simulation control. The diagram to the lower left depicts where the terminals are placed throughout the YP. You have one in the galley, you have actually 2 in the CIC. The big screen is the CO's tactical display and it's optional. And the bridge terminal is located up in the pilot house. The local area menu looks like this. And for those of you who were at my last presentation, you'll notice the addition of the wide area network and also the flag. Don't shut up here, I'll explain what that is in the next slide. We had to upgrade several aspects of the system when we started this semester, one of which was the configuration file. This allows you to type in valuable information such as your IP address so other clients can connect to the server on board the YP. This is for the local area network. And also the hull number, so everybody has their own unique identifier of the wide area network, because everybody has a unique hull number. We also have the addition of a right-click menu. Any track you see on the NTDS display, you can right-click on it and bring up a quick menu to engage, drop, or classify that contact. In addition, you also have the two flags. These are the two different teams. You have stars and stripes. So when you go to start the match, you're going to have either one of those two teams to play as. And finally, I added a title screen with the options to exit. You have an options menu. You have Fleet Battle, which is that's the wide area network. That involves GPS, local area networks on board HYP, and your wide area network system. Single player, multiplayer, I'll describe what that means towards the end of the brief, but pretty much that's going to be intended to replace Fleet Command. Next slide, please. All right, wide area network. This is for you, sir. You have a local area network, which is nothing more than a series of computers that exchange information over Ethernet. And as you can see down here, we have cables running everywhere. And wide area network is similar in that you're exchanging information between different computer terminals, but you're going wireless. So there's no more cables, and now you've increased the distances from a couple of feet to several miles, depending on the type of radio propagation you're using. Now, how do we actually do it? There is kind of a train of equipment here. You have the YP-TDS server, and the GPS unit is feeding its longitude and latitude into the server about once a second. And then that server is also generating its own tactical data. Some of it's simulated, some of it's derived from your inputs. And then it sends that to something called a terminal node controller, or TNC. The TNC takes binary information and converts it to an audio envelope. It's actually sound, you can hear it. And then that's broadcast out through the HF packet radio. And conversely, you're also receiving broadcasts from other YPs, which are then run through the TNC again, turned back into binary information, and sent to the YP-TDS server for computation and processing. And that'll display as contacts on your screen. Next slide, please.
HF?
Yes, sir. High frequency radios. Of course, the actual way this works is a little more complex. I'll get into the details here. I'm going to define a term for you. The YP-TDS uses packets. Each packet's 48 bits. A packet's nothing more than just a discrete chunk of information. It's a position, or it's a command to do something. I'll go into much more depth next slide. It's going to take this 48 bits of data, and it's going to convert it to a 64-bit string. And the reason why it has to grow in size is because the TNC uses that bit number 5, you have those circles up there. Bit number 5 is actually reserved for internal TNC commands, so you can't use it. And in order to balance it out, because I ended up with an odd number of bits left, and encoding that on an 8-bit stream, 7-bit stream, it's kind of difficult, so I went ahead and I dropped the second bit, and I ended up with only 6 bits per 8 bits on the TNC, hence the growth from 48 to 64. Now once that was done, down here you have an example of what it looks like. You have the YPG-687, and that's the whole number of YP. That's broadcast on every transmission, so you know who you're getting the packet from. The 00 you see after that's the timestamp. That's going to tell you how old the packet is. So sometimes you could have a packet queued, ready to send, but it won't send until a couple seconds later while it waits for everybody else, because you can't have everybody broadcast at once, because you'll have a collision, and then both packets, or however many packets are broadcast, destroyed. So to avoid that, we'll get into the mechanisms I use to avoid that in a second. Finally, the data that actually looks like all these characters, the encoded data, are actually typable characters. The TNCs are capable of broadcasting text back and forth to each other. We're just using it for something a little more advanced. Next slide. All right, here's the definition of the packet. Each one of these spheres you see look kind of like Skittles. Each one of these represents a single bit, and I'll go over individually what each one of these do. First, I'll tell you that packets come in two different flavors. You have a condition update and a position update. Position is going to tell the wide area network, everybody connected to it, where you are physically in the world. And the condition update is going to tell them how your systems are doing, what level of damage have you sustained, and some other vital things, including the ability to launch weapons. And I'll explain that further as we go. The first part of the packet I want to describe to you is a net ID. It's 6 bits, so it can represent a number between 0 and 63. Now this is a limitation of the system, because that means you can only have 63 both fictitious and real participants in your network. And but that's fine. Aegis uses 127, so if I'm half as good as Aegis with this, I'm happy. you have the packet type, which can carry 4 different values, but we're only using 2 different types of packets at this point. The latter bit is there for expansion for later versions. Total damage can carry a value from 0 to 127. It's going to be an actual percentage of damage that your own condition is currently at. So that way you can tell how much damage an enemy has received after getting hit by a harpoon, let's say, or how much one of your own team members is damaged to sustain. Fuel / crew, depending on whether you're a ship or an aircraft. If you're an aircraft, this will read out how much fuel you have left. If you're a ship, and you're an actual midshipman manned ship, this will report how many crew on board have been virtually killed, which means they've been sent to the galley. Sensors, each one of these is a 1 or a 0, defined at the very bottom of the chart. You can see there's 5 sensors that can be toggled on or off, 1 for on, 0 for off. This is so you can put certain sensors in MCON. MCON's missions control. You don't want to be tracked when you're out at sea. You want to be more stealthy. You'll stop emitting certain signals. For instance, you'll shut off your radar so the enemies can't detect you. YP-TDS will eventually emulate this same ability to do that. And so therefore, you can turn off your sensors and turn it back on. Everybody on the net will know. System works similarly. You have 7 different systems, depending on how much damage you've sustained. Those systems will come on offline. For instance, if I sustain a direct hit to my engineering plant, I may lose engineering. That engineering bit at the very bottom will go to 0. Everybody will know that I lost engineering. Furthermore, I'll also be restricted. I won't be able to use my lee helm anymore and be dead in the water until such damage is repaired. Weapon type. If this is anything besides 0, that's telling everybody that I want to launch a weapon. And my target is going to be the target ID. Now, this is important because I don't actually control my own weaponry. And I'll get to why that is next slide. But there's a master server, which is kind of like the server of the wide area network server. Then there's a remote server, and that's the client of the wide area network server. So there's masters and remotes. And I'll describe to you in the next slide how that works with the weapons. But before I do that, I'm going to talk about the first packet type, which is your position update. And our demonstration today will show you this thing at work. And it has a 16-bit number for latitude and a 16-bit number for longitude. This, once again, is your physical position on the world. And then finally, depth and altitude. Now, this isn't really used for YPs. YPs typically don't go below sea level. If they do, that's bad. And they don't fly either. So this is for submarines and aircraft in the future. Next slide. All right. And finally, as mentioned before, there's a remote server and a master server. And the difference is the remote server is only responsible for reporting its own position, GPS, and its own condition updates. The master server, on the other hand, is slightly different. In addition to its own position update and condition updates, it's also responsible for all fictitious contacts, such as missiles, land installations, submarines, civilian traffic, anything that's not midshipman driven. And in addition to that, the master server also is the one responsible for starting the network. And should the network lose focus and there's lots of collisions, the remotes will all stop, and the master will send out a pulse to resync the network. So it's responsible for starting it over. HF is actually a very spotty spectrum to work with. Oftentimes you have a lot of packet loss. So the system is designed to where every one of those packets, if I were to lose 1 or 2 or 3, it won't crash the entire system. It'll just wait until you get the next one. So I only pass full values. And in addition to that, the master server is ready to resynchronize the network should it require it. And as far as the weapons launch, get back to that. If you remember, the condition update sends you a number of weapon type. That tells the master server that you want to launch that weapon. The master server is responsible for all automated contacts, which includes your weapon. So the master server actually spawns that contact from your position and targets it at your target. And that's how it works. Next slide. All right, now I'm going to go ahead and fire up a demonstration of the actual project itself. And I'd like to point out that this is not ready to actually be fielded. This is simply a proof of concept, proof that it can actually work. All right. Now, before I start, I also want to point out, too, that from this laptop on over to here, it represents one YP. And Dr. Stahl's laptop on all the way over here is another YP. There are no wires connecting these two. We have no Ethernet cables. We have nothing that's passing information. Instead, we're going to use those two radios to broadcast tactical information just within this room. Sir. Yes. All right. All right, so we've disconnected.
You want to walk them through that process?
Yeah. On this one? Sure.
Yeah.
Go ahead and go back to the main menu, sir. Okay, this is the main title screen, and the only option that we have is either to exit the options menu or Fleet Battle. Fleet Battle is our wide area network. We're going to go ahead and go through that. All right, now, this is your local area network configuration. Dr. Stahl is sitting at a server terminal, which means he's always going to be the bridge. So he's going to create server, and now other terminals may connect to his terminal. So right there, he just connected the galley, which is also damage control central. All right, now we have the CSC connected. Now he's going to go to the wide area network page. I'm going to do the same. And I'm going to be the master server. Dr. Stahl is going to configure his station as the remote server. I'll let him go first. All right. Now, as the master server, I have the responsibility of selecting what mission we're going to use. Right now, I load up a generic test mission, which just involves 2 IPs. Once I do that, I have to select my team. It can either be stars or stripes. And that's what stars looks like. And once I do that, my system is going to wait. Okay, it just pulsed out a packet over the radios that was received over there. This packet contained what team I was on, what my home number is, and then I'm a master server. Dr. Stahl now, he knows what team I'm on, so he's not able to pick stripes because I've already picked that team. So now he's going to pick all 11 stars. All right. Now that we're both talking to each other, we just got a lockstep. So as I'm saying to him, he said right back to me that what we're doing is maintaining synchronization at this point. The synchronization uses something called round robin, but it's event driven instead of time driven. So I will always wait for him to broadcast to me before I broadcast back. This is how we avoid a collision. If I don't get one from him because it's lost because of atmospheric interference, then I'll wait for an entire second. He'll know that I'm waiting because he hasn't heard from me in a second by that point. So he'll stop broadcasting, and I'll transmit the basic pulse. So at this point, we're going to go ahead and launch the simulation. All right.
Where we cross it.
Yes. So all of our terminals on this side. All right. So everybody has remotely now been entered into the nautical display simulation. At this point, if you direct your attention over here to this side, you can see my terminal. You have a mini map, move around. You have a nautical display, you can zoom in and out. These are all my friendly contacts right here. And in addition, I can hit R, and notice the radar envelopes that they have. Notice that since these guys are all on my team, all those unknown contacts you see are being relayed to me. I can see everything my friends can see. This is the heart of net centric warfare. Over here is my own position. And there's some suspicious guys up here. Of course, if we look at Dr. Stahl's screen over there, that's his team. And he has his own radar range that he can turn on. And you can't see too much, but all right. Now, because we don't have GPS in this room, and even if we did, we have to get up and run around the computers, we're going to go ahead and simulate moving vessels. drag mine around.
You should be watching the center screen. As soon as he comes within line.
Okay. I just entered his radar range, but I'm still unknown because I haven't got close enough for visual identification yet. Uh-oh. So at this point, of course, I can click on him, bring up the profile. That tells me I just visually identified him, I know who he is. And he can do the same to me. Some other options we have. Go back over here. You have different civilian traffic. These are all automated. So the computer's controlling everything over here. And let's say these are civilians. This right here, for instance, is the Titanic. Well, if there's too many civilians cluttering the screen, or other contacts I don't care about, I can right-click on them and go to drop. That allows me to ignore them. This is just to reduce clutter. If I want to bring them back, there's a toolbar at the top, loaded full of commands, and one of which is to show all contacts. Brings everybody back. I can also blanketly ignore all visuals, bring them back. Wrecks, if I happen to have destroyed anybody recently, they'll leave behind a wreck, and I can reduce clutter by ignoring those. I can turn off the track numbers, put them on top or bottom, get rid of the velocity lines. And there's also a thin symbol mode, which looks a little more true to the actual Aegis system you see in CICs for Harley Brooks and Ticonderoga and such. For tools, there's coordinate grid. We've already seen the radar range mini map. I can also auto hide the toolbar, leave it on. Damage control. This is important because this allows you to log your damage. Now, unfortunately right now, we cannot launch weapons at each other because the weapon launch packets are not functional yet at this point. But I can simulate damage by hitting the D key. So if you look at my terminal over there, I just sustained a hit virtually. Fire and flooding, 26% damage in the engineering, or in the after propulsion. Now, something else to point out is that I can do anything about it. Because this right here is actually the pilot house. This terminal is located in Damage Control Central. Sir.
Display.
Well, this is my turn. And, as it was. Sir, why don't you go ahead and simulate some damage? Dr. Stahl is also going to simulate some damage. Alright, so he's got fire, and only his terminal on his ship, since it's Damage Control Central, can extinguish that fire. This is for the onboard referees to make use of. If someone has done a drill to the satisfaction of an onboard referee to extinguish a white smoke fire, which would be class alpha, then they would go to this menu and click extinguish fire. If you sustain too much damage, then eventually your ship will be destroyed. Before I do that, I'm going to go ahead and show you briefly launching weapons at the bag. Alright, so you can right click on them, go to engage, and here it gives you a list of weapons you can use. So we'll go ahead and go with the harpoon. You have this entire range circle that tells you the maximum range. Now, all the ranges are scaled down because the distances involved. So now I have a harpoon in the air. And, alright, it hit him, but he was only damaged 2%. So not a very good hit. Of course, I can shoot at him again. That time only hit him for 12. And that demonstrates weapons capability. Now, if I sustain too much damage, in either flooding or fire, gets to be the maximum of 100%, then eventually my ship will sink. So I'll go ahead and simulate that real quick. And we're all sorts of trouble here. And finally, ship is lost, it's game over, and my YP has sunk. All right, Dr. Stahl wins.
Good choice.
All right. Okay, so that concludes the actual demonstration portion of it. Now I'm going to talk a little bit about what our future intentions are. As mentioned before, I am leaving, graduating. This is going to be some stuff I'd like to see happen. The person who's going to pick up for me, I'd like to see this get worked on. One of the things I want to address is system flexibility. We're using USB right now for practically nothing. Everything is serial, and serial is going away because laptops nowadays, you get them, everything's USB, and your serial ports are kind of a thing of the past. So what I'd like to do is replace GPS instead of having a serial USB and any other external device for that matter. There are ways to use serial, like for instance I have an adapter here for a PCMCIA card for a laptop, but if we switch everything over to USB, it cuts cost. Wireless LAN, as you can see, there's a lot of wires here. Installation on board a YP would get pretty complex because I have to run these long Ethernet cables through watertight doors and all the way to the galley from CIC. So by doing it wireless, that'll make installation really easy. Alternative wide area communications. This is important. I'd like to eventually make this satellite-based instead of line of sight. That will extend our range. And if I increase the frequency, right now we're using HF, I'd much rather use VHF or UHF. That would not only increase our data rate, but also reliability. And there are other midshipman projects that have proven that you can use VHF comms to transmit data, such as GPS. I'd like to use OpenGL or DirectX to replace my current graphic system. I'm using something called Allegro, which are open source freeware libraries. While they work and they're very easy to use, they don't make much use of hardware acceleration. And also, I can't guarantee compatibility with future Windows operating systems. That's mitigated by OpenGL and DirectX, which is always up to date. Portfolio of scenarios. Scenario is a mission that's defined using a UML type script that anybody can write. Requires no programming experience. Currently this isn't implemented, but it's definitely something we want to see. And I'd like to have a portfolio of these things, different missions to show off different capabilities of YP-TDS. For realism, I want to have sound. Already this has begun. By splitting left and right stereo channels, you can separate out console sounds such as menu clicks and beeps with sounds that you want to have broadcast over 1MC on the YP, such as CWIS firing and 5-inch firing off, missiles launching, things of that nature. Fictitious track AI, that is, I want the automated computer contacts to behave in such a way that it's difficult to determine who's real and who's not based just upon their behavior. Integrate real YP sensors. This more applies to any future YPs that might come out. I'd like to have it to where you're actually using real radar, surface search radar contacts, and integrate those directly into YP-TDS. The SPID64 on the YPs right now is analog and very difficult to do, but if we ever do switch over to digital radars, this might be possible. I'd also like to integrate fathometers and compass bearing, things of that nature. VPF, vector product formatted charts. As mentioned before, I'm using something called VSB, which is a scan image of a paper chart. Very difficult to line these things up because of different scales, and also when you go to ship charts, there's also a lot of pre-processing involved. VPF would allow me to, on the fly, render a chart of any given area as long as I have the data files for it. So it allows us much greater flexibility where we can go. Training applications, I want to integrate the loose bridge simulator. For those of you who haven't had a chance to check it out, it's a three-dimensional multi-screen surface warfare simulation system. And it's perfect for simulating an additional ship that can be entered into the YP-TDS WAN and then allow you to participate. I also want to integrate the single and multiplayer functions so that you may take the YP-TDS and derivative of it anyway into class. So there's no GPS, no YPs, no wide area network. And this would pick up the functions of fleet command so that you can engage in tactical battle scenarios while in the classroom. And simulation improvements, I want to eventually record all packets being sent and since I have the times and the GPS coordinates and all the other pertinent data about the simulation, I can actually replay the entire scenario just based on that. I'd like to put it in a three-dimensional replay, and that way students, midshipmen, could watch the battle and critique each other and learn from mistakes, etc. Scenario director, I want it to where a shore station or perhaps another YP could be responsible for entering in, injecting in neutral contacts such as oil tankers, Cessnas, but do it during the battle. And they'd also more or less act as an observer. And finally, improved contact control. For the automated contacts that are supposedly on your side, such as E2C Hawkeyes or ballistic submarines, since they're automated, I'd like it to where you could still be able to manipulate them through a menu, through the YP-TDS. So we want to add that functionality. Ladies and gentlemen, this concludes my presentation. If there's any questions, I'd love to answer them.
How well does it scale with the current HF implementation? How many YPs do you have out there transmitting and still maintain your net latency that you'd like to have?
That's accurate. We've done a test to see what the maximum packet size is. And although we've only used 2 TNCs and 2 radios, I'm estimating it up to somewhere around 7 or 8 YPs before the lag between reporting their GPS positions gets so much that it wouldn't be practical. Yeah.
Are you planning to introduce charts, so say when the YPs are transiting to New York or Rhode Island, they can come together and have a little simulation out there in the waters?
So you mean the charts would update as you're going from New York to Rhode Island?
Yes.
Yeah. Although this isn't intended for a navigation program, I don't see why that couldn't work that way. Although I certainly would have to put the disclaimer there that this is not for navigational purposes. But certainly, yeah, I can't see why not. The only thing you have to overcome, though, is the range. Right now, the HF, you're still using line of sight with HF, which is only approximately 30 miles, and we've never actually done a long-range test, so I really don't know when that's out. Sir?
Do you have the capability to manually put contacts or track that in addition? Say you're playing the scenario, manually put tracks as you go along?
Not yet, sir, but it is possible. All I have to do is add the functionality to the user's, one of the user menus. Now,
Have you thought to backup capabilities for the server?
actually I have, ma'am. It's a good point. As of right now, the remote servers will have copies of whatever the master server has by virtue of the packets it sends out. Should the master server go offline, although it doesn't, I don't have this implemented yet, but it certainly could be. The next remote server's, the closest hull number, the next incremental hull number, will automatically assume the master server role. And once he sends out his master server pulse, if the former master server hears that pulse, he drops to being the remote server.
In your round robin interrogation, so the master sends out a pulse, in the 2-ship scenario, it responds, and then the master sends out another. If you had 7 ships, does the master send out 1 pulse, and then each in turn comes back before the master sends out another, or does he have to interrogate each one?
It's he'll send out his pulse, and according to their hull numbers, everybody else in order will send out their pulses, and then it'll come back around to him. And his pulse will also normally be a lot longer because he's handling all the fictitious combat, fictitious track events. All right. Any other questions? Thank you very much for coming. Of what the YP-TDS could represent for here at the Academy. What I'm really hoping we can do is network together as many platforms as possible. CSNTS boats, you have your USNA Flying Club. This would all be over satellite communications, and then we could do. I mean, as far as what we could do, it'd be really quite a lot. And it's probably not too visible in that front here. We could simulate joint warfare and get a lot of people into a battle at once. So that's kind of the future vision, and hopefully this will be realized. Thanks again for coming.
Jeff, what did you do started with battle simulation, and you went from battle simulation to wide area network.
Yes, sir. My initial focus when I started it up was just to, thank you, sir, was just to build an NTDS simulator, and then after that, I started thinking, I was like, well, why not just put this on several terminals throughout the LAN? And it turned out that that was actually not as hard as I thought it would be. And then I'd already had the idea for a wide area network in my head. In the semester, I was able to find a method of doing it.
That's the HF radios.
No, thank you, sir. The great part I love the most is that the YPs already have the equipment, and that's something that cutting costs is. These are, sir, how much are these radios?
Those are 2,000, but you can get them equivalent for about 800. That's top of the line.
Definitely, definitely a plus, I think.
Digital HF radio.
One of the current problems on the YPs, we've been doing this HF networking with the YPs since about 1991 or 92. And the problem is, I don't know, 5 years ago they put this alarm system on there that was not